All right, page 2. We've got 24 chocolates. 4 of the chocolates have cherry centers. 2 chocolates are selected without replacement. All right, so the without replacement, this is telling me, let's do a tree diagram. Let's see what I can do here. Okay, so I've got a box of chocolates. 4 have cherry centers. So I just need a way to mark this. Let's see. Let's go with a like this, and this is going to have chocolate. This is not going to have chocolate. Excuse me, cherry centers. So on the first round, 4 of them, let's see, there's 24 total, which means that 20 out of the 24 won't work. The second time around, let's see, I'm taking 2 chocolates out. So let's see, 4, there's going to be 3 left out of 23. But here, there's going to be 20 out of the 23. See, that's chocolate, chocolate, not chocolate, not. This is going to have, let's see, there's 4 ways still to get chocolates there, and it looks like 19 ways to not work it. Okay, so this tree diagram is probably going to get everything that I need. Overall, let's see, this just might be useful. Let's see, this is 2 chocolates. This is 1 cherry, excuse me, and this is 0 cherries. Okay, so what's the probability of getting 2 with cherry centers? So to answer this one, I just need to go, what's the probability of getting this? So it's 4 over 24 times 3 over 23. And I get that as being, let's see, 12 on top and is that 552 on the bottom. So let's see, wants it as a fraction. So that'll be, I'll take that one, but I think it goes down to 1 in 46. All right, I'm going to need to refer to that. Diagram every once in a while here, but let's see what we can do. Okay, so what's the probability of getting at least 1 chocolate with the cherry center? Well, there's 2 ways I could do that. I could calculate like the 2 and the 1, but if I just calculate the none and take that away from 1, that should actually split it up nicely. Okay, so if that's the case, I just need what's the probability of getting 0? Okay, so let's scroll up. Let's scroll up here. Okay, so I just need to calculate this guy. So that was 1 minus, let's see, that's going to be a 20 over 24 times 19 over 24. Oh, excuse me, over 23. And I get that as being, let's see, okay. Save that fraction for just a second. I get that as being, what is it, 380 over, it's still going to be 552. So that'll be 552 over 552 minus, okay, so I can just go across the top. And I get, is that 172? That looks pretty good. And let's see, throw that into a calculator. I would take the 172 over 552, but I think that simplifies down to this value. That should work nicely. Okay, given that the second chocolate chosen did not have a cherry center, what's the probability that the first did not? Oh, okay, so this is that's the Bayesian style. So I could go back up to that table. So given that the second did not have a cherry, so I need an n at the end, right? So what's the total probability? So I remember that it looks like this is going to be first C and second N. So this is going to be, let's see, I would need all of them, right? So I could do a Cn plus Nn. Okay, so I need to go back up and take a look. All right, if I've thought this through well enough, okay, so this second one can't be, right? Second doesn't have it, so I need, the second one isn't, and the second one isn't. Okay, so I can set this up. I just need these guys, so this here and that there. So I'll copy that down. All right, the C and the N, that was a 4 over 24 times 3 over 23. So that's just the top part. Then I'm going to use that again. But I have to also take into account the one that had none of them. So that'll be it's the 20 over 24 times 19 over 23. So a little bit of calculation and simplifying. I'm noticing that all of these have the same denominator, so that's going to end up disappearing overall. So this is going to end up being, let's see, 4 over 3 is 12, or 4 times 3, so that'll be 12 plus, oh gosh, what are you, 380? So I get that being 4 over 23. This should be pretty straightforward. I need, let's see, a probability distribution. I need like an x's and a probability of x's, which lets me go with, I could do like a 2 and a 1 and a 0. And let's see, the probability of getting 2 was the 4 over 24 times 3 over 23. The probability of getting 0, we did that when that was 20 over 24 times 19 over 23. And then this last one was, oh gosh. Okay, so I think I've got this at 4 over 24 times 20 over 23 plus 20 over 24 times over 23. Okay, so I just need to simplify it. Well, I don't even have to simplify it that much. It's all over, what's that number, 552. So this will be 12 over 552. This is going to be 380 over 552. That's an 80, which means that this last one here will be, okay, I get 160 over 552. And that actually right there, that's my answer. I'll just make sure that my work is shown. So in any given year, the probability of a major hurricane hitting North Carolina is, what, 3%? So assuming that hurricanes are independent of each other, what's the probability of experiencing a major hurricane in the next 10 years? Well, okay, so the probability of 0, probability of more than 0. I guess you could have like 10, but all I need is really like probability of getting none. So I could do like 1 minus the probability of getting none of them. Okay, so that's going to make my calculations a little bit easier. So the probability of getting 0 is actually, let's see, that's the, it'd be not 3%. It'd be like 0.97. So 97% chance of getting none once, right? Because it's 3% yes and 97% no. But the chance of getting that 10 times in a row is just like multiplying them out. So that means that it'll be 1 minus 0.97 raised to the 10th power. This is going to give me my answer right here. And calculation-wise, let's see, that's going to be about 0. You're going to need to check this. 2625. Let's call it 8. Okay. So let's call it, it says to the 3, so 263 on that. All right, on the ballot was Initiative 7. Okay, nobody cares about that detail. So this sentence doesn't matter. If enacted, we don't care about this. Okay, so this is going to be information that's useful. And so we've got a for and against. So if you choose somebody at random, oh, okay, so what's the probability that the person voted for the measure? Okay, so for the measure, that's So number success over number fail. Or no, excuse me, that's number total. So the number of successful was 1, 2, 6, 5, 1, 2, 3. And the number total would be 1, 2, 6, 5, 1, 2, 3 plus 1, 8, 3, 9, 4, 1, 4. So whatever that ends up being, let's see, throw it into a calculator, and I get something like this. So that's, what does it say? Percentage with 1 decimal place. So that's 40.8%, right? Because the rounding. All right, that should do it.